All right, good morning. My name is Abby Romberger. I work at the West Shore School District at Redland High School. I currently teach Algebra 1 and AP Pre-Calculus at my school. I am a math teacher there. I am in the STEM program. I think that STEM is fascinating. I love the connections between the subjects. At my school, we have something called the Da Vinci program, where we actually have a science, technology, and math teacher all in one class, and they work through students on different projects. I think that it's been really interesting taking new courses and learning more about the STEM, and I think it's a really growing field, and I hope to keep learning more about it. My view on how students learn science, so before the reading, I kind of felt like the students learned most science from the hands-on experience they got. Some instruction as well, but mostly the hands-on experiments. And then after the reading, I felt like students really learned science from not only the experiments but instructions, but also then reasoning, explaining the results of the instructions. They need to reflect on both the instruction and the experiment and the results in order to increase their knowledge. It was really kind of eye-opening what misconceptions the kids come in with to science class. Not being a science teacher, I don't get to see that very often, I don't think. And so the barriers is that students come in with these misconceptions of science because of something that they've already seen out in the real world. And then they have this idea, and it's really hard for teachers to kind of show and explain why those misconceptions are incorrect. The misconception of what it means to do science. I feel like I fall in that category. We did the experiment or whatever, the lab that the teacher had set up, and then we were done. And we looked at the results, and the results were what the teacher, had intended for us to get. And that's not necessarily doing science. I also feel that students really struggle to reflect on their own understanding. I feel like students have this misconception that they understand the material because they're able to apply it or redo it the next day, but can they do it in 5 days? And do they actually truly understand what they're doing, or are they just repeating information from the teacher? I also think that kids really struggle to apply what they learn from instruction into that real life. I see that in my math class. Kids don't understand how coming up with equations and stuff is actually a real life thing. And I think we just do it in math class if we're a real world problem, but don't see how they could actually do it. I think that science is the same way. I don't think they could apply, and they talked about that in the chapter 11 with that cart that they were pulling across the table by the string with the weight and the pulley, about how the students were good with that material, with the instruction, but as soon as I was applying in real life, they had really struggled with that. In my math classroom, I really try to work on the students persevering. I really watch my questioning and getting the students to realize that they need to keep working through the questions. I do have the students reflecting on their own learning. I actually do a before and after reflection quiz, and in homeworks I sometimes will be like, just reflect on the lesson. What went well? What are you still missing? I try to make connections to them, to that real world and to other disciplines. I liked the one quote in page 478 where it says, students need to persevere in learning and trusting that the teacher will help guide them to the big idea. That is my goal. I want to guide them to that big idea and show them how math can be used in the real world, in this case also science and STEM fields. So my perspective of STEM is that there is a flow between the 4 disciplines. So they are going to be separate from each other, but also involve the other disciplines. So graphing was mentioned in the figure 8.6, and I thought this was a great one, right? I can introduce it in math, but it's used in science, it's used in engineering. We can use technology to graph this, and we can apply it in technology as well. So there should be a flow of concept, processes, resources between the disciplines. But they're still kind of separate from each other, and again, just kind of flow and connect between the two.